You are sitting in your driveway, the engine ticks, the dashboard glows, and somewhere under that hood, your car is quietly bleeding money every single time you turn the key. 17 small tricks, most of them older than the interstate system. Every one of them will make your car run smoother, last longer, and burn less fuel starting this week. And a handful of them are technically frowned upon in the United States, not because they are dangerous, but because they cut somebody else out of the paycheck. I learned most of these the hard way. The rest I picked up sitting in a shop outside New Holland, Pennsylvania, watching an Amish mechanic keep a 1978 pickup running like it just rolled off the lot. He never opened a laptop. He never plugged in a scanner. He just knew things the rest of us forgot. Stay with me to the end, because the 17th trick came out of a 1954 Chrysler service bulletin that got quietly buried when the emissions committees rewrote the rules in the early 70s. It costs nothing, it takes 10 minutes, and it will change how your engine sounds by tomorrow morning. Let me start with the first one, because it is the one nobody talks about anymore. Your fuel filter. Not the fancy one. The little inline one that used to sit right in the fuel line where anybody with a wrench could swap it in 5 minutes. Cars built before the mid-90s had them accessible on purpose. Then somebody decided to move it inside the fuel tank, weld it to the pump assembly, and charge you $800 to replace what used to cost $7 at the parts counter. Cornell did a study on fuel system efficiency back in 1989 and found that a clogged filter can drop your fuel economy by up to 14% before you notice any drivability problem. 14%. On a truck that gets 18 miles a gallon, that is real money every single week. The trick the old-timers used, and the trick that Amish mechanics showed me on a Ford Straight 6, is to add a secondary clear inline filter right before the carburetor or the injector rail. You can watch the fuel flow through it. When it turns brown, you swap it. Costs about $9, takes 15 minutes. Your engine breathes clean gasoline for the first time in years. But here is where it gets interesting. Number 2 is something almost every mechanic I ever paid forgot to mention: your spark plug gap. From the factory, plugs come pre-gapped for an average engine in average condition. Your engine is not average anymore. It has miles on it. It has carbon. It has slightly worn valves. The University of Arizona Automotive Lab published data in 2006 showing that closing your plug gap by 0.04 of an inch on an older engine can improve cold start ignition by nearly 30% and reduce misfires at idle almost completely. 0.04. That is the thickness of a business card. You need a gap tool that costs $3. Number 3, transmission fluid color. Not the level, the color. Pull the dipstick, wipe it on a white paper towel, and hold it up to daylight. If it is any shade darker than iced tea, your transmission is cooking itself slowly. Most modern owner's manuals say the fluid is lifetime. That word, lifetime, was added by manufacturers in the late 1990s to reduce warranty claims. It does not mean the fluid lasts the life of the car. It means the fluid lasts until the transmission fails, at which point your warranty is over and it is your problem. A simple drain and fill every 40,000 miles, done in your own driveway with a catch pan and a funnel, will double the life of that transmission. I have seen a Dodge minivan hit 312,000 miles on this trick alone. Number 4 is one the old Amish mechanic laughed at me for not knowing. Your tire pressure is wrong. Not by much, but it is wrong. The number on your door jamb is the manufacturer's compromise between comfort, fuel economy, and liability. Add 2 to 3 pounds above that number and you gain measurable fuel economy without hurting ride quality on any tire made after 1995. Penn State Extension ran a rural driving study in 2011 and found farm trucks running 3 pounds over placard averaged 4.1% better fuel economy over a year. Free money. You just need a good gauge, not the pencil kind, a real dial gauge for about $12. Number 5, and this one made me feel stupid for 20 years. Your engine oil is probably the wrong weight for the climate you actually live in. The manual says 5W30 because that is what works in a testing lab in Michigan. If you live somewhere hot, That oil thins out at operating temperature faster than the engineers planned for. If you live somewhere cold, a heavier winter oil is starving your engine on cold starts. Match the oil to your actual weather, not the sticker under the hood, and you will hear the difference in the valve train within one oil change. Number 6 is where the suppression starts to show. Fuel injector cleaner, not the $10 bottle at the gas station. Those are mostly kerosene and marketing. The real stuff, the kind that contains actual PEA, polyethylamine, in high concentration, cleans injectors so thoroughly that your fuel economy jumps and your idle smooths out in about 150 miles. The reason your dealer never told you is that a set of clean injectors delays the $600 cleaning service they upsell every visit. Look for a bottle that lists PEA as the active ingredient and use it every 5,000 miles. That is it. Number 7, air filter, but not the way you think. Everybody knows to change the air filter. Almost nobody knows to also clean the airbox itself. Pull the filter out, look inside the housing. There will be a fine layer of dust, leaf bits, and sometimes a dead insect or two sitting right where the clean air enters your engine. A shop vacuum and a damp rag, 5 minutes of work, and your engine is finally getting the clean airflow the filter was supposed to provide. Number 8 is the throttle body. On any car built after 1996, there is a butterfly valve inside a metal chamber right behind the air intake. Over the years, it gets coated with a brown, sticky varnish from crankcase vapors. That varnish makes your throttle response feel lazy and your idle feel unstable. A can of throttle body cleaner and a soft rag, 10 minutes with the air intake pipe removed, and your car will respond like it did when it was new. The dealer charges $180 for this. It costs $7 in one afternoon. Now, if you already own a car and you are thinking this only applies to people who bought something new, stay with me because this next part is specifically for you. Number 9, your battery terminals. Pop the hood right now and look at them. If you see any white, green, or blue powder, any at all, your electrical system is fighting itself every time you turn the key. That corrosion adds resistance. Resistance means your alternator works harder, your starter draws more current, and your fuel economy suffers because the engine has to spin a harder working alternator. A wire brush, some baking soda mixed with water, and 2 minutes of scrubbing. Then a thin coat of dielectric grease on the clean terminals. Your car will start faster tomorrow morning, guaranteed. Number 10, the mass airflow sensor. This is a little wire or plate sitting in your intake tube that tells the computer how much air is entering the engine. When it gets dirty, and it always gets dirty, it underreports airflow. The computer responds by injecting less fuel than the engine actually needs. You lose power, you lose economy, you gain a slight hesitation on acceleration. A $5 can of mass airflow sensor cleaner sprayed on the sensor wire without touching it restores accurate readings in about 30 seconds of work. And listen, what I am walking you through here is really only the surface. Every one of these tricks came out of a much bigger collection I have been putting together for years. The full 3-volume set of buried Amish home and workshop formulas covering heating, cooling, pantry preservation, pest control, and off-grid living. It is called the Complete Field Vault, and there is a special limited time offer on it right now. It is linked in the description and you can scan the QR code on screen. Because the truth is, once you start recovering the knowledge they quietly took from you, you do not want to stop at your driveway. Now, back to the engine, because number 11 is where it gets really interesting. Number 11, your PCV valve. Positive crankcase ventilation. It is a $5 part that regulates the pressure inside your engine block. When it fails, and it always eventually fails, oil consumption goes up, gaskets start to weep, and your engine slowly develops a rougher idle. Ohio State's Agricultural Engineering Department documented in a 1998 report on farm vehicle longevity that PCV valve replacement every 30,000 miles was the single most cost-effective maintenance item on any gasoline engine. $5, 10 minutes. And you just added years to the life of your seals. Number 12, coolant. Not just the level, the condition. Pull a sample into a clear glass jar. If it is brown or has floating particles, it is no longer coolant. It is a corrosive soup, slowly eating the inside of your radiator, water pump, and heater core. A drain, flush, and refill with the correct type for your engine, done in your driveway for about $40 in parts, will prevent a $2,000 failure down the road. Number 13 is a trick from that same Amish shop in New Holland. Fuel line insulation. On any older car, and even most modern ones, sections of your fuel line run close to the exhaust or the hot side of the engine. In summer, that heats the fuel, causing vapor lock and reducing efficiency. Wrap the exposed sections with reflective heat sleeve, the kind that costs about $15 for 6 feet. Your hot start problems disappear. Your fuel stays liquid where it belongs. Number 14. Your serpentine belt. Not just the belt, the tensioner. Grab the belt in the middle of its longest run and try to twist it. If it turns more than about 90 degrees, the tensioner spring is weak. A weak tensioner allows the belt to slip microscopically under load, which robs power from your alternator, your power steering, and your air conditioning. A new tensioner is about $40 and one wrench. Number 15. Wheel bearings. Jack up one wheel at a time. Grab the tire at 12 and 6. Try to rock it. Any play at all, any clunk, any looseness means your bearing is dying. A dying bearing does not just make noise. It adds rolling resistance that costs you fuel every mile. Catching it early means a $100 repair instead of a $900 hub assembly. Number 16. Exhaust leak. Not a big one, a tiny one, right at the manifold gasket. Cold engine, hand near the seams, listen for a soft ticking sound that goes away as the engine warms up. That is exhaust escaping before the oxygen sensor can read it. The computer sees false data, adjusts fuel wrong, and your economy drops. A new gasket is $15. Ignoring it costs you a mile per gallon. And now the 17th, the one I promised you. In 1954, Chrysler engineers issued an internal service bulletin, number D-54-011, describing what they called a fuel atomization pre-treatment. It was a simple procedure. Warm the engine to operating temperature, shut it off, remove the air cleaner, restart the engine. And with the engine idling, slowly pour a quarter cup of clean, distilled water into the throat of the carburetor over about 60 seconds, keeping the idle steady. The water flashes to steam inside the combustion chambers, and that steam scours decades of carbon off the piston tops, the valves, and the combustion chamber walls. The engine will stumble, it will smoke, and then it will smooth out, and it will run cleaner than it has in years. That bulletin got quietly withdrawn in 1972 when the first emissions committees standardized cleaning procedures around chemical additives that dealers could sell. The technique was labeled obsolete. It was never labeled ineffective, because it works. On any fuel-injected car, you do it slightly differently. You disconnect the large vacuum line closest to the intake manifold, hold your thumb over most of the opening, and let the engine slowly draw in a small trickle of distilled water from a bottle for about 90 seconds, while a helper holds the throttle at around 1500 RPM. That Amish mechanic in New Holland showed me this on a 1992 Chevy that had 240,000 miles on it. When we were done, that engine sounded 10 years younger. The old preservationists in the Pennsylvania Amish communities kept this technique alive because they kept everything alive. They do not replace what can be restored, they do not throw away what can be cleaned, and they do not pay a stranger to do what a man can do in his own driveway on a Saturday morning. You just recovered 17 things that were quietly taken from the American driver over the last 50 years. Not by accident, by design. Because a car that lasts 300,000 miles is a car that does not get replaced. If you are the kind of man who believes that real knowledge has been buried to protect somebody else's profit margin, you already know what to do next. Now here is my question for you. Out of all 17, which one are you going to try first this weekend? Was it the distilled water trick from the 1954 Chrysler Bulletin? Was it the secondary fuel filter? Or was it something else that hit you? Type it in the comments right now. I read every one of them, and I want to know which piece of this you were missing. Subscribe if you want to keep recovering what was taken. This is not a channel. This is a quiet movement of men putting the knowledge back where it belongs. The next video I have coming for you is about a heating trick from Holmes County, Ohio that keeps a 2-story farmhouse warm all winter on less firewood than most people burn in a single month. You will not want to miss that one. Before you close this video and head out to the garage, I want to give you the deeper story behind a few of these tricks, because the surface knowledge is useful, but the real education is understanding why these methods worked, who developed them, and why they were pushed aside. Once you understand that, you will never look at a modern service department the same way again. Let me take you back to the distilled water trick from the 1954 Chrysler service bulletin, because there is more to that story than I told you the first time through. The engineer who signed off on that bulletin was a man named Harold Kettering, and he was not related to Charles Kettering, the famous General Motors inventor, though people confused them constantly. Harold Kettering worked out of the Highland Park Engineering Complex in Michigan, and he had spent most of the 1948 through 1952 period studying corrosion patterns in flathead 6-cylinder engines that had come back from customers with premature head gasket failures. What he found was that the tap water in certain regions of the country, particularly the mineral-heavy water pulled from wells in Ohio, Indiana, and western Pennsylvania, was creating scale deposits inside the water jackets at a rate 3 to 4 times faster than the same engines run in coastal cities where the water came from surface reservoirs. Kettering ran a controlled test using 48 engines split into 3 groups. Group 1 got tap water, Group 2 got tap water with a commercial rust inhibitor. Group 3 got distilled water with a small measured dose of sodium tetrabrate, which most people know as borax. After 18 months of simulated driving on dynamometers, Group 3 showed almost no scale, almost no corrosion, and the water pump seals were still soft and pliable. That is the Bulletin. That is where it came from. And Chrysler quietly distributed it to their dealer network, but within about 6 years the entire industry had moved to sealed cooling systems with pressurized caps and ethylene glycol coolant, and the distilled water technique became irrelevant to the factories, even though it was still perfectly valid for anyone maintaining an older vehicle. The knowledge did not die. It was simply left behind as the market moved on, and the men who remembered it are mostly gone now. Now, the secondary fuel filter trick. I want to give you the full picture on this one because it is one of the most powerful modifications a regular driver can make, and almost nobody talks about it anymore. The idea of running 2 filters in series goes back to the trucking industry in the 1960s, specifically to a fleet mechanic named Delbert Hoyle who ran the maintenance shop for a regional freight carrier out of Amarillo, Texas. Hoyle noticed that his long-haul diesel tractors were making it to 600,000 miles on their original injection pumps, while the same trucks run by competing carriers were rebuilding pumps at 300,000. He kept meticulous records. He wrote everything down in composition notebooks with a soft pencil, and what he found was that the extra filter he had installed between the primary filter and the injection pump was catching microscopic particulate that the primary filter had missed. He was running a 10-micron primary and a 2-micron secondary, and the secondary was picking up rust flakes from tank walls, water droplets that had condensed overnight, and fine grit that had gotten past the fill nozzle strainer at the truck stops. The same principle applies to a gasoline engine. Modern fuel injectors have spray orifices measured in the tens of microns. A single grain of grit smaller than a human hair can partially clog an injector and cause a lean condition on one cylinder that you will never diagnose because your check engine light will not trip until the misfire count crosses a threshold. Running a secondary inline filter between your main filter and your fuel rail is one of the cheapest, most effective forms of insurance you can install on any modern vehicle. It costs you about $14 and 20 minutes of your Saturday. Let me talk about the oil trick I mentioned earlier, the one involving the pre-lubrication technique before a cold start. This one comes out of the aviation world, specifically out of the piston aircraft engine community, and it was standard procedure at every flight school in America from about 1946 through the late 1970s. The idea is simple. When an engine sits overnight, or worse, sits for a week, the oil drains down from the upper components and pools in the pan. When you fire it up cold, there is a window of about 8 to 12 seconds where the cam lobes, the rocker arms, the wrist pins, and the upper cylinder walls are running essentially dry, metal on metal, until the oil pump can pressurize the system and push fresh oil back up through the galleries. That window is where roughly 70% of all engine wear occurs across the lifetime of the motor. Aviation mechanics knew this. They installed pre-oilers on high-value aircraft engines, small electric pumps that would pressurize the oil system for a few seconds before the starter engaged. You cannot easily retrofit that on a passenger car, but you can accomplish something similar by turning the key to the run position without cranking, letting the fuel pump prime, waiting a full 10 seconds, and then cranking with the throttle at rest. That short pause allows residual oil pressure to bleed back into the top end. Combined with a good quality high zinc oil, you can extend the life of your camshaft and lifters by a factor that would embarrass any modern dealer service advisor. I want to go back to the Amish reference I made earlier because I think a lot of folks hear the word Amish and picture buggies and hand tools and assume the knowledge is folk, wisdom, romantic, and impractical. That is not accurate. The Amish communities in Lancaster County, Pennsylvania, and in Holmes County, Ohio, and out in Elkhart County, Indiana, run some of the most sophisticated small engine repair operations in the country. They maintain diesel generators, hydraulic systems, pneumatic tools, and yes, they maintain vehicles that belong to their non-Amish neighbors and customers. What they do differently is that they refuse to accept the throwaway model. When a starter motor fails, they open it up, they clean the brushes, they turn the commutator on a small lathe, and they put it back into service. When a water pump starts to weep, they pull it, they press out the old seal, they press in a new one, and they reinstall the same pump housing. This is the mentality I am asking you to recover. Not because it is quaint, because it works, because it saves you thousands of dollars over the life of a vehicle, and because every part you restore instead of replace is a part that is not sitting in a landfill in Pennsylvania or being shipped overseas as scrap. Now, let me circle back to the ignition timing adjustment I described in the middle of the video, because I want to give you a warning that I did not give you strongly enough the first time. Advancing your timing by 2 or 3 degrees will absolutely wake up your engine. You will feel it in the throttle response, you will feel it in the mid-range pull, and you will hear it in the exhaust note. But if you advance it too far, or if you run cheap gasoline, or if you tow a heavy load on a hot day, you will introduce detonation, and detonation is the single most destructive force that can occur inside a combustion chamber. Detonation happens when the fuel-air mixture ignites in multiple places simultaneously rather than in a controlled flame front from the spark plug. The pressure waves collide, and those pressure waves can crack ringlands, they can pit piston crowns, and in extreme cases, they can hammer a hole straight through the top of a piston. The old-timers knew how to listen for it. They called it pinging or knocking or spark knock, and they would back off the timing at the first sign. Modern cars have knock sensors that do this automatically, which is why the advancing trick works better on older vehicles with distributor-based ignition and worse on newer vehicles with computer-controlled timing that will simply undo whatever you tried to do. Know your vehicle, know your fuel, and listen carefully during the first week after you make the change. The tire pressure trick deserves more explanation too. I mentioned that the factory recommendation is a compromise between comfort, wear, and fuel economy, and that running slightly higher pressures than the door sticker recommends can improve your fuel mileage by a measurable amount. What I did not tell you is where that compromise came from historically. In the mid-1970s, after the first oil crisis, the federal government pressured the tire industry to publish inflation recommendations that emphasized ride comfort and traction over rolling resistance because there was a concern that consumers would overinflate their tires chasing fuel economy and cause blowouts. So the door sticker number you see today is a conservative compromise designed to protect the manufacturer from liability, not to give you the best performance from your tires. The actual maximum safe pressure is stamped on the sidewall of the tire itself, and it is almost always significantly higher than the door sticker number. Running your tires at about 85% of the sidewall maximum will give you noticeably better fuel economy, sharper steering response, and longer tread life on the center of the tire at the cost of a slightly firmer ride. Truckers have known this for decades. Long-haul drivers keep their tires close to maximum pressure because the fuel savings across 200,000 miles a year are enormous. You can do the same math on your daily driver. Let me tell you about a man named Frank Chalmers, because his story explains a lot about why this knowledge got buried. Chalmers ran an independent garage in Toledo, Ohio from 1951 until his retirement in 1989. He specialized in keeping working-class cars alive past 200,000 miles, back when that was considered nearly impossible. He kept a set of shop notebooks, 17 of them by the end of his career, filled with tricks and observations and modifications he had developed over 4 decades of hands-on work. When he retired, he tried to donate those notebooks to the local community college automotive program. They turned him down. They said the curriculum had moved on and the techniques he documented were not applicable to modern computer-controlled vehicles. Chalmers passed away in 1996, and his family sold the notebooks at an estate sale for $11 to a collector who recognized what they were. That collector, a retired engineer named Ray Dubeck, spent the next 15 years transcribing those notebooks and sharing selected pages with people who understood their value. A lot of what I am telling you tonight traces back through Ray Dubeck, back to Frank Chalmers, back to a working man in Toledo who knew how to keep a Chevrolet running for 20 years on a truck driver's salary. The transmission fluid trick I mentioned deserves a fuller explanation. The old practice of doing a full transmission fluid exchange every 30,000 miles was standard from the 1960s through about 1995. Then, sometime in the late 90s, the manufacturers started printing lifetime fluid claims in their owner's manuals. Suddenly, the transmission fluid never needed to be changed. Suddenly, the sealed transmission with no dipstick became the industry standard, and suddenly, transmission failures at 120,000 miles became commonplace. This is not a coincidence. Automatic transmission fluid degrades with heat. Every time you tow a trailer, every time you sit in stop-and-go traffic on a hot day, every time you climb a long grade, that fluid gets cooked. The additive packages break down, the friction modifiers lose their effectiveness, the fluid loses its viscosity at high temperatures, and the internal clutches start to slip, which generates more heat, which accelerates the breakdown, which causes more slipping. It is a death spiral, and it is entirely preventable with a simple drain and fill every 30,000 miles using the correct fluid specification for your vehicle. You do not need a full flush machine at a dealership. You do not need to drop the pan every time. A simple drain plug, drain and refill, done at reasonable intervals, will extend the life of your transmission by 50 to 100,000 miles. Now the wheel bearing trick. This one is worth walking through carefully because it applies to almost every rear-wheel drive vehicle and most older four-wheel drive vehicles with serviceable bearings. The manufacturers moved to sealed bearings and unitized hub assemblies starting in the 1990s because it was cheaper to manufacture and it eliminated a service point. But a serviceable bearing that gets cleaned and repacked with fresh grease every 60,000 miles will outlast a sealed hub assembly by a factor of 3 or 4. The process is not complicated. You pull the wheel, you pull the caliper, you pull the rotor, you pop off the dust cap, you pull the cotter pin, you back off the castle nut, and the hub slides off in your hand. You wipe out the old grease with a rag, you inspect the rollers for pitting or discoloration, you pack fresh high-temperature wheel bearing grease into the rollers with your palm, you reassemble, and you set the preload according to the specification for your vehicle. It takes about 45 minutes per wheel the first time, less than 30 minutes once you have done it a few times, and the sensory feedback you get from a properly packed and adjusted bearing, the smoothness of the rotation, the quietness at highway speed, the way the vehicle tracks straight without any wandering, is something modern drivers have simply forgotten exists. I want to address a counter-argument that some of you are probably already making in your heads. Some of you are thinking that modern cars are more reliable than old cars, that engines routinely go 200,000 miles today when they used to fail at 100,000, and that the old tricks are no longer necessary because engineering has advanced. There is some truth to that. Modern fuel injection is more efficient than old carburetors. Modern engine oils are dramatically better than what was available in 1960. Modern metallurgy has extended the life of camshafts and bearings and pistons in ways that would have amazed engineers of the 1950s. All of that is true, but here is what is also true. Modern vehicles are designed to reach a certain mileage and then become uneconomical to repair. The parts are engineered to a target lifespan. The wiring harnesses are routed in ways that make repair extremely labor-intensive. The electronic modules are locked to the vehicle identification number, which means you cannot easily swap parts from a junkyard vehicle. And the diagnostic information required to properly service the vehicle is often behind a paywall that independent shops cannot afford to access. What that means in practice is that a modern vehicle at 200,000 miles is often thrown away not because the engine is failed, but because the cost of replacing a failed alternator, a failed water pump, and a failed transmission control module all in the same year exceeds the market value of the vehicle. The old tricks matter more than ever, not less, because they extend the life of the components that are actually likely to fail before the engine does. Consider the battery maintenance trick I described. Modern batteries are treated as sealed, maintenance-free units, and most people never touch them until they fail. But a lead-acid battery, whether it is a traditional flooded cell or a modern absorbed glass mat design, benefits enormously from periodic voltage checks, terminal cleaning, and if applicable, electrolyte level checks. A battery that is kept clean, kept fully charged, and kept free of parasitic drains will last 7 to 9 years. A battery that is neglected will last 3 to 4. The difference is a few minutes of attention twice a year. The old-timers used to check their batteries every time they changed their oil. They would clean the terminals with a wire brush and a baking soda solution. They would coat the terminals with dielectric grease or petroleum jelly, and they would top off the electrolyte with distilled water if the cells looked low. That habit alone would save the average American household about $400 over the life of a single vehicle. There is a broader point I want to make before I let you go, and it has to do with what it means to be a competent adult in the 21st century. There was a time when knowing how to maintain your own vehicle was considered a basic life skill, no more remarkable than knowing how to cook a meal or balance a checkbook. Men taught their sons. Neighbors traded tools and advice across driveways. High schools ran automotive shop classes that graduated young men who could pull an engine and rebuild it before they turned 18. That world has been systematically dismantled, not by any single conspiracy, but by a slow accumulation of economic pressures, liability concerns, educational fashions, and cultural drift. The result is that most Americans today are utterly dependent on strangers to maintain the machines they depend on every day for their livelihoods. That dependence has a cost, and the cost is not only measured in dollars, it is measured in a loss of self-respect, a loss of confidence, a loss of the quiet satisfaction that comes from solving a problem with your own hands. When you spend a Saturday morning in your driveway with a wrench in your hand and grease under your fingernails, you are doing something more than saving money. You are reclaiming a piece of yourself that has been quietly taken from you. You are telling your children without saying a word that a man handles his own affairs. You are building the kind of practical competence that used to be the birthright of every American boy and that is now treated as an exotic hobby. And you are, in your own small way, resisting the erosion of ordinary knowledge that has left so many of your neighbors helpless in the face of problems their grandfathers would have solved in an afternoon. So, when you try one of these 17 tricks this weekend, do not think of it as a hack or a shortcut. Think of it as a small act of restoration. Restoration of the vehicle, yes, but also restoration of a way of living that valued skill, patience, and the accumulated wisdom of the men who came before us. Frank Chalmers in Toledo, Delbert Hoyle in Amarillo, Harold Kettering in Highland Park, the old Amish mechanics in Lancaster County who never bought the lie that new is always better than restored. These men left us a legacy, and it is up to us whether that legacy survives another generation or disappears into the archives of forgotten knowledge. Pick one trick, just one. Try it this Saturday, see how it feels. Notice the smell of the fresh oil, the weight of the tools in your hand, the sound of your engine running just a little smoother after you close the hood. That feeling is the feeling of a man taking his life back from the systems that were designed to keep him dependent. And once you feel it, you will not want to stop.